Okay, so at the second part of Module 2 is loosely related to strings in that we're going to start to learn how to have a kind of a conversation with the user. So most programs of any really real interest are going to require some input. And while some programs will get their input from a text file, they'll get their input from the internet, the overwhelming majority of programs do interact into some way with the user. So when the user starts the program itself, it'll probably ask them for some information. And it's important for us to understand exactly how to do this um, going forward because most of our programs will wind up needing some input from this user. So in order to get any data from the user, we need to actually ask them first. So when you run your program and you're gonna ask them for specific data, one of the things you want to try to do the best that you can is be as specific as possible. Right. So a user of your program should never have to look at your source code. They should never have to talk to you to understand how to use it. You're gonna display a message to the user that's very clear regarding what you need from them. So in Python 3, all input or most input from the user is done through a single function call called input. So pretty standard. The input function takes a message, a string. All right, so it could be a variable, it could be a literal string, it could be a concatenation of some strings. It takes a single variable or a single parameter and displays that to the screen and then waits for the user to type something. And then whatever the user types in will get returned back to you. So just like the string function, the int function, the length function, they all return things back to us that we can use. Input will return the string that the user types in from the screen. So I want to just kind of illustrate this by way of example. So let me pull up a program that we looked at briefly in the last video. And let me make this font a little bit bigger. And so I'd set up a program that simply printed out, let's go some team, and team was held in a variable, so I had it at Mets. So if I was to go run this, I'd type in Python 3 input ex.py. Oops, forgot to save that file when I put that code in. Let's rerun it. All right, so it'll print out "Let's go Mets." So let's assume that in some strange universe you might not like the Mets, and so my program is actually going to ask you for the team that you like. So I still have this variable called team, but it's not going to be hard coded to a specific team. Instead, I'm going to call the print function or the input function. Sorry, and I'll say what is your favorite team, and the prompt usually should have some spaces afterwards so the user's not typing right on top of the string, and I'll show you what that looks like in a second. And then everything else in the program is exactly the same because the team is now going to be assigned to whatever string that the user actually types in, and I'll just run the program. So now when we write this, what is your favorite team? Again, you see the cursor is a couple of spaces away from that colon. That's probably a good idea. We never really specified a sport here, so I'll say Giants. Let's go Giants. Like I said, if you leave out that space in the colon, of course Python's not going to tell you that anything's wrong here, but if I run that, my prompt is sort of sitting right on top of the question mark, so it just doesn't look quite as good. So, right, but it worked exactly the same way. Right, so our standard prompt will probably have some spaces in it. All right, so let's revise this a little bit, or kind of change course. I want to take a look at how Python deals with input that might be represented as integers or floats. Because lots of times we'll ask the user for numeric data, not just a string. So I'm just going to say x equals the user input. So please enter a number. And then I'm going to print x plus 5. All right, so that's a pretty straightforward, simple program. I'll switch back over. And I'm going to type in a number. And you'll notice that I immediately get an error. All right, so it says can't convert int object to string implicitly. Right? And so what's it actually talking about? Well, it's actually trying to convert 5 to a string, right? Which is a little strange because we know that x is actually an integer. I typed in 3. But from Python's standpoint, everything that the input function returns is always a string. Right, no matter what. So Python doesn't look into the x variable and figure out, hey, this kind of looks like an integer. Let me convert it to an integer. It just treats it as a string. And so what Python's seeing is that you've got a string and you're trying to add a number to it. And Python would require me to actually convert 5 to a string. So to get rid of that error message, I could do something like this. I'd convert 5, the integer, to a string explicitly instead of implicitly. If I was to run that, right now I get 25, but now I'm going to point out where we're getting that 25 from. Right? The user types in 2, that's a string, and I've concatenated it with the 5, the string version of 5. That's probably not what we really wanted to do. So this is a classic example of where, if you can make a change to your program that will make the error go away or the crash go away, but it actually doesn't really solve the problem because probably I want to print out 5 plus whatever the user types in, right? And so to make sense of this, what would we want instead is to convert x, the string, into an int. Right? That's probably more along the lines of what we originally wanted to do. So now if I run it, if I type in 2, I'll get 7. All right, so now it's really doing the arithmetic because the x string value is getting converted to an int. So int x is going to return the integer value 2, and then I'll add them together and print them out. And print can accept an int and print that out as a string. So something you want to be aware of when you write a program like this, though, is that we're assuming that the user listened, right? We're assuming that the user read our prompt very carefully. And generally speaking, that's probably a bad idea. Users rarely listen to us as programmers. We'll ask for something. We're going to hope with our fingers crossed that they actually type in a number. But if they don't, if they type in something like hello or ABC, we're going to try to take that hello or ABC and convert it to an integer. And as you'll see that's not going to work very well at all. So at this point, please enter a number. That's just a prompt. Python doesn't know that it should only accept a number or anything like that. The user just types in a string. And of course now we've got invalid literal for int. I mean, this is kind of a cryptic message, but basically it's saying ABC is not an integer. At this point, there's nothing we can do about that. We'll learn later on when we cover exceptions how to catch these exceptions, how to deal with them appropriately, so we can get a little bit better with it. But at this point, it's something that you need to be aware of. So as you write programs, realizing that converting user input to integers and floats is always a potential point of failure. All right, so let's flip back to the slides here. And I want to talk about the difference between Python 2 and Python 3 again. So as this course proceeds, we'll probably talk a lot less about these differences. But because the input structure and printing changed so much in version 3, I want to point this out to you because it is different than what the textbook talks about. So in Python 2, there are actually 2 different ways to get user input. The input function. So the input function that you just saw me use actually was quite different in Python 2. It evaluated what the user typed in. Right? What does evaluate mean? Well, evaluate means it would actually try to determine what the value or the expression results in that you typed in. So for instance, if I asked for an expression, the user types in 3. Right? the string 3 would be typed in, but the input function in Python 2 would actually interpret that. It would go into the string and say, you know what, this looks like an integer, so I'm going to return an int. Right? If the user typed in 3 plus 4, Python would go in and evaluate that, and it would return back to me 7. Right? So it would take the string and try to evaluate it as it was a piece of Python code. It's very powerful, but it led to a lot of tricky and hard to handle errors, right? And so in Python 2, this input function behaves very differently in that it actually kind of introspects into whatever the user types in and tries to evaluate it. Incidentally, if I tried to do print, x plus 5 and the user typed in 3, now this would actually work. It would print out 8 because it would have evaluated x to actually be the value 3, not the string 3. In Python 2, if you didn't want that functionality, if you wanted the user's input to just simply be returned as a string, you could certainly do that. You had to call the function raw input. Right? So raw input as opposed to input would just return back the string value. And again, just back to our original example, if the user did type in 5 here, it would not work. We would really need to change that int or that string to an actual int. Right? And so it would have to do something like that. So where does this all come from, or why are we talking about this? So although Python 2's and Python 1's original version of input sort of seemed like a good idea at the time, years of best practice experience kind of led us to realize that that was probably a bad thing. It opens up a lot of room for errors, a lot of security concerns to have a user actually type in a string and then have Python try to evaluate it. So rather than continuing to have that legacy support, Python 3 removed the functionality entirely, but they also renamed the input function, or I should say they removed the raw input. They kept the input function, but they re-implemented input to work the way the raw input worked in the first place. All right, so it's a little confusing. The easiest way to think about this is that in Python 3, input returns a string, always, no matter what. In Python 2, input returns the evaluated expression. If you wanted an actual string, you'd have to call raw input. In this course, we're going to be using Python 3, so you're really not going to have any use for raw input. Occasionally, the textbook, because it is using Python 2, will use raw input, or it will write a program. It will show you a program that's using input, and it might not work exactly the same way on your machine when you run it in Python 3. So this is just something to be aware of in general in the background, that there are some differences between these two versions. Ultimately, Python 3's strategy, I think, is a lot better, it's a lot cleaner, and it's a lot easier to work with.